Hi everybody. We're going to work through one more lesson before Thanksgiving. I just want to cover this very briefly today. It's about solving absolute value equations. And if you are following along in your book, this is an extension from chapter 2. It's on right about pages 148 through 151 if you want to read through the examples. What I want you to do today, just quick and easy, watch this little video, do some practice problems on page 150 in your book. Just 5 practice problems. I want you to come back next week prepared to talk about these things. We'll practice more on Monday and Tuesday, but be ready. I want you to have covered this, and we'll talk about the absolute value inequalities at the end of next week. So we're going to push through here really quickly. We usually spend quite a few days on this, but we don't have that luxury of time this year. So, solving absolute value equations. You've seen this symbol before, most of you, those parallel vertical lines, they mean the absolute value. So if I say those parallel lines with an A in the middle, it means the absolute value of A. And what that means is it represents how far A, that value of A, is from 0 on the number line. So if I were to draw that, here's 0, might be this direction, A units away, or this direction, A units away at negative A. Okay, so we're used to that. A lot of you have seen that in either in junior high or elementary school, the absolute value of A. Because that absolute value of A means distance, it's always represented to be positive. It always means it's positive. So if I ask you for the absolute value of 6, you would tell me it's 6. If I ask you for the absolute value of negative 6, you'd also tell me that it's positive 6. Please notice that doesn't mean it doesn't mean that to take the opposite of it. It doesn't mean the opposite sign. It doesn't mean if it's negative it turns positive, and if it's positive it turns negative. It means to take the positive value. Again, it's the opposite. It's the distance from that number to 0 on the number line. So that's kind of our elementary school version. What we need to do for high school is we're going to solve equations involving the absolute value. So we're going to find all the values of x that make a given equation true. So we'll be solving for that x. And sometimes now our answers will be negative. Instead of you just spitting out what's the absolute value of negative 2, now I'm going to be asking you what values of x make this equation true. And sometimes those numbers will be negative numbers, and that's okay. These take a little while to wrap our brains around. Once we get the hang of them, they're not that bad, and we'll keep it really simple this year. So here's an example. If I tell you that the absolute value of x is equal to 3, we want to solve that equation. That means to find all the values for x that are 3 units away from 0. Now if we draw that on the number line, here's 0. There are 2 different numbers. The number 3 is 3 units away from 0, and the number negative 3 is 3 units away from 0. So often with these absolute value equations, we're finding 2 different values that make the equation true. So this is the first time kind of in math that we're not seeing just one value, we're seeing 2 different solutions for the same equation. So here's how we're going to solve these. We'll start with this same simple case, and I want to show you how to solve these. So what we do is we take that absolute value equation, and again, this is about as simple as it gets, and we think of those 2 vertical lines to remind us that there are 2 different possibilities. If that thing that's inside there, if that x is equal to 3, then we have the absolute value of 3 equal to 3. We have a true statement, so x equals 3 is one of our solutions. But for our second case, what we do is we take that, whatever's inside those absolute value bars, and we set them equal to the opposite of that number. Because that could be a different case as well. In this case, that would tell us the absolute value of negative 3. Hey, that's also equal to 3. So x equals negative 3 is another solution to this equation. So whatever's in there, however complicated or however simple, we write down 2 cases. And again, we use those bars to remind us that there are 2 cases. Break it off into 2 cases. Case 1, case 2. Case 1 is the positive of whatever that number is. Case 2 is the opposite, the negative of whatever that number is. Okay? Always, always, always do the same thing. So here's a slightly more complicated example. We have absolute value of x minus 4 is equal to 7. My case 1, if the inside of that thing, if x minus 4 is equal to 7, then its absolute value will equal 7. But also, if what's inside those bars, if that x minus 4 is equal to negative 7, when I take its absolute value, I'll also have positive 7. So I broke it up into two different cases. Again, one is the positive version, and one is the negative version. Always do that, always those two different cases. And then we solve, so we would add 4, x would equal 11. Or if I add 4, x equals, so here I've got a negative 3. So let's take a look back at what that means. If I were to substitute that 11 into the absolute value symbol, absolute value of 11 minus 4, that's the absolute value of 7, which is 7. So I got a correct answer there. If I were to substitute the negative 3 in, I'd have absolute value of negative 3 minus 4, which is the absolute value of negative 7, which is also 7. So I have a second correct answer. And very often with these problems, there will be two different answers, or two answers. Okay, so we set them up, case 1, case 2. Again, it looks a little weird. We got a negative answer as a solution. That doesn't mean that this value is negative. It means that when we substitute that negative number into the original equation, we come up with a true statement. Okay? When we're doing these equations, though, before we do anything else, we need to isolate that absolute value sign. So if there's anything outside the absolute value, let's get rid of it and let's move it to the other side. So in this case, I'm going to divide by 4 first. So instead of having that absolute value equal to 24, I divide by the 4, I isolate it, I get x minus 5 equals 6. And now I'm going to set up those two cases. Case 1, x minus 5 equals 6. Case 2, x minus 5 equals negative 6. In other words, again, if the inside of this thing is equal to negative 6, then I have a true solution. And I'll solve by adding 5. X would equal 11. Or if I add 5, x will equal negative 1. So there's my two solutions. I want to check them. If x is 11, then 4 times the absolute value of 11 minus 5 should equal 24. Well, that's 6. Its absolute value is 6 times 4 is 24. X equals 11 is one of my solutions. If I try the negative 1, 4 times the absolute value of negative 1 minus 5, and again, following order of operations inside first, that's negative 6. I take the absolute value, that's positive 6 times 4 is 24. So my two correct solutions are x equals 11, x equals negative 1. It's setting up those two cases that are getting me the solutions here. So our rules, we want to first isolate the absolute value, then set up the two cases, then solve. I put in check here because there are some numbers, some problems that don't have solutions. We'll talk about those after Thanksgiving. But we do want to check answers. So I want to try just a couple of problems here in quizzes before we go. Okay, so typical question here. 5 times the absolute value of x minus 8 equals 2. First thing I want to do is isolate that absolute value. So I'm going to add 8 to both sides. I get 5 times the absolute value of x equals 10. It's still not isolated. I'm going to divide by that 5. I get the absolute value of x equals 2. And now I set up my two cases. If x equals 2, I have a correct solution. If x equals negative 2, I have a correct solution. There's nothing more I need to do to that x because it's kind of isolated within the absolute value sign. So there's my two correct solutions. And hey, whoever made up this quizzes does not have the correct answer here. Our correct answer should be 2 and negative 2. So let me try this one just quickly. Again, I need to isolate the absolute value. I'm going to subtract 10 from both sides. I get absolute value of negative 2n is equal to negative 60. Now there's nothing else outside the absolute value, so I'm going to set up my two cases. Negative 2n equals negative 60, and then negative 2n equals 60. And I would solve both by dividing by negative 2n. I'm sorry, by negative 2. And I get n equals 30 or negative 30. So I feel like this should be the right answer. However, I told you to check back in the original equation, right? If I put in n equals 30, that's telling me the absolute value of negative 2 times 30 plus 10 would equal negative 50. Well, that's the absolute value of negative 60 plus 10 equals negative 50. Absolute value of negative 60 is positive 60. This is not true. In fact, the same thing would happen if I put the negative 30 in there. This actually has no solution, and we'll talk about those when we come back from Thanksgiving break. It's the fact that that isolated absolute value is equal to a negative. That's going to be a no solution. So just be aware those are out there. Again, we'll talk more about them after Thanksgiving. All right, so I want you to try just 5 problems in your book. On page 150, we'll do 1, 3, 5, 7, and 9. All right, and then just be ready to go on Monday. Have a check-in tomorrow. We'll do something, just a little bonus activity. All right, have a great Thanksgiving, guys. Bye-bye.